Welcome back. In this video, we're going to go over section 3.4, which is about some applications of geometry. We're going to start with triangles, including the angles in a triangle and perimeter and area. So first of all, some labeling that we're going to use for a triangle. We'll use capital letters A, B, and C for the vertices of the triangle. We may also use those same letters to refer to the angles in the triangle. And then for the corresponding opposite sides, we'll have lowercase letters A, B, and C. So little a is opposite big A, little b is opposite big B, and so on. Additionally, when we do area, we'll have use for the height, which I'm calling h here, and that's the distance from one side, the perpendicular distance, to the furthest point away on the triangle. So that would be the vertex at B. The formulas that we need are, first of all, the angle sizes. A plus B plus C have to add to 180. In any triangle, the sum of the angles is 180 degrees. For the perimeter, which we'll call P, that's the sum of the side lengths, and that's the distance around the triangle. And then additionally, we need the area for the triangle. Formula for the area is 1/2 the product of the base and the height. So let's try some examples, first of all, involving angles. So in this first one, it says the measures of two angles in a triangle are 31 and 128 degrees. We want to find the measure of the third angle. So I'm going to let x be the third angle. And then I'm going to write down an equation. So I know that the total of the angles is 180 degrees in a triangle. So I know that 31 plus 128 plus x, the angle that we're trying to find, has to make 180. Okay, so that'll be our equation to solve. So let me combine my terms on the left side. We have 159 plus x makes our 180. Subtracting 159 from both sides, we'll have 180 minus the 159, and that makes 21 degrees. Back and put all my degree signs on. There we go. All right, so the third angle would be 21 degrees. Okay, in the next problem, it says one angle in a right triangle measures 56 degrees, and then we want to find the measure of the other small angle. A right triangle is a triangle that has a right angle in it, which you'll usually see a little square box in the corner where the right angle occurs. So here, this would be an example of a right triangle. And a right triangle then has to have a 90-degree angle in it. If we know that the total of the angles in a triangle is 180 for any triangle, if 90 of them are taken up by that right angle, that means that the other two smaller angles together have to add up to the remaining 90. So that's the background we need for this question. So here it says one angle in a right triangle measures 56 degrees. Well, it's obviously not the 90-degree angle, it's the 56-degree angle. And then the other small angle, which we'll call x, we would like to find that. We know that the total of those two angles has to be 90 degrees. So x will be 90 degrees minus 56 degrees. So that is 34 degrees. Okay, the next problem is about area. Here it says the area of a triangular painting is 126 square inches. The base is 18 inches. From this, we want to find the height. So first of all, the formula for area, 1/2 the product of the base times the height. The area we're told is 126 square inches. The base we're told is 18 inches, and from there we wanted to know the height. So we'll have 126 on the left side. Half of 18 is 9. So this means that our height has to be 126 divided by 9. So let me do that. Looks like 14 inches for the height of this triangle. Okay, and that takes us to the end of that problem. All right, so here, back to angles, it says the measure of one angle in a right triangle is 50 degrees more than the measure of the smallest angle. We want to find the measures of all three angles. So take a minute, pause the video, try this one yourself, and then restart the video and see how you did. All right, so in this one, we're trying to find all three angles. We're told that this is a right triangle, so that means automatically one angle is 90 degrees. And so then we just really need to know the other two. Of course, we could do this with only one variable. We don't need two variables to get this done. So that means that we should be able to express all of the quantities, other quantities in the question in terms of one variable. So it says the measure of one angle in a right triangle is 50 degrees more than the measure of the smallest angle. So what they're calling one angle is described in terms of the smallest angle. I'm going to let X stand for the smallest angle. Okay, so X will stand for the smallest angle, and then one angle, it says, is 50 degrees more than the measure of the smallest angle. So now we have an expression for all three of these angles, the 90-degree one, the smallest angle, and then the medium-sized angle. And all those together have to make 180 degrees. So simplifying, we'll have 2x plus 140 equals 180. So 2x equals 40, and x is 20. So that was the smallest angle. The next one, the middle-sized angle, has to be 50 more than that. So it's 20, 70, 20 degrees, 70 degrees, and 90 degrees. Okay, and a quick mental check will tell you that all three of those add up to 180 degrees. And of course, the 70 degree one is 50 more than the 20. The next piece we have is on the Pythagorean Theorem, which is a fact specifically about right triangles. And it goes like this. If you have a right triangle with two short sides, called legs in this context, legs A and B, and a long side, which has a funny word, hypotenuse, traditionally called C. If you have one triangle with three legs, two legs and one hypotenuse. The two legs are A and B, the hypotenuse is C. Here we are. Then what the true fact is that the sum of the squares of the two shorter sides equals the square of the long side. That is, A squared plus B squared will equal C squared. The typical first example you see of this is a 3, 4, 5 right triangle. And to check, we can say 3 squared plus 4 squared. That's equal to 9 plus 16, which is 25. That's 5 squared. Turns out that that's always true if you take, for a right triangle, if you take the two shorter sides, square them, and add them up, you get the length of the longer side squared. So let's try applying it. Here it says a right triangle has legs with length 10 and 5. We want to find the length of the hypotenuse. So let me write down the Pythagorean theorem again. I find that if I write a new formula down every time I use it, it makes it easier to remember and also makes it easier to put the right things in the right places. So here the two lengths are 10 and 5. So we will have 10 squared plus 5 squared equals C squared. So 100 plus 25 is our C squared. So then C squared is 125. C is the square root of 125. And so we'll want to simplify that square root of 125. I have too much here, too much going on. C is the square root of 125. There we go. So if we rewrite the radicand, the part inside here, 125 as 25 times 5, then this will be the square root of 25 times the square root of 5, or 5 square roots of 5. There's that as a simplified radical, or you could just leave it for now as the square root of 125. Make sure if you're using some kind of online software to do homework, that you pay attention to the directions. You may be asked to use your calculator to give a decimal answer for this, or more than likely just give an exact answer with the square root sign. Okay, let's try that again. A right triangle has hypotenuse 15 and shortest leg 3. We want to find the length of the third leg. So here, pause the video, try this yourself, restart it, and see how you did. Okay, so here we have c squared is a squared plus b squared. We're told that the hypotenuse, that's the c, is 15. So we have 15 squared is equal to 3 squared plus b squared. Here I've assigned the 3 to the a. It doesn't matter if you made the b be 3, then it will still be okay. 15 squared is 225, and then 3 squared is 9. Taking 9 from both sides, our b squared will be 216. So then b will be square root of 216. Okay, and then again, we can simplify the radical if we want. We'll rewrite the radicand as, let's see, 4 times 104. No, 2 times 54. That's not helpful. 216 is 4 times 54. That's 2 square roots of 54. We can do better than that because 54 has a factor of 9 in it, right? That's 9 times 6. 2 root 9 root 6. That'll be 6 square roots of 6. Okay, or maybe you can just leave it as the square root of 216. All right, here we're given one as a picture. We have 2 legs of size 12 and 5, and then we want to find the hypotenuse of C. So we can say 12 squared plus 5 squared equals C squared. Okay, doing the arithmetic, 12 squared is 144, 5 squared is 25. So C squared will equal 169. So C equals the square root of 169, and that's 13. So that longest side here is going to be 13. We'll spend more time working on square roots at a later date. If you're finding those at all off-putting, let me know. We can talk about them. Okay, so this will be a fun last question involving triangles, then we'll go on to rectangles. We want to find the area of an equilateral triangle that has sides of length 1. So whenever you're going to start a problem, if it's something geometric like this, it's a good idea to make a sketch. So let me draw the triangle first. It has sides length 1. And then for inventory of helpful information, we know the area of a triangle is 1/2 base times height. So here the base is 1, but it looks like the issue on this is we don't know what the height of the triangle is. So that's the problem, isn't it? So what we'll do, what you should do, is pause the video, take a minute, try it yourself, and then restart the video and see how you did. But we'll continue. So whenever you've got a problem involving triangles and there's some missing length or length about the triangle you don't know, you want to think about the Pythagorean theorem among your different choices. So Pythagorean theorem we just learned about, so it seems logical. We're going to go with h for the side that we want for height. If the whole base of the equilateral triangle is 1, I'm going to split that in half right here where you see that height. So at the base, we're going to have a base of 1/2, and then we know the hypotenuse is a 1. So even though this question didn't come right out and say Pythagorean theorem, we're going to actually use it right here to help us find that unknown height. So we'll say h squared plus, to be plus, h squared plus 1/2 squared equals 1 squared. H squared plus 1/4 equals 1. So h squared equals 3/4, and h is square root of 3 over 2. Okay, now we've finally done it. We've got that height, 1/2. The base is 1. And the height, square root of 3 over 2. Overall, multiplying across, we'll have the square root of 3 over 4 as the area on that equilateral triangle. Okay, so that's it for triangles. We can go on to a bit about rectangles next. Everybody watching knows what a rectangle looks like, but just to be sure, we'll go over some high points. A rectangle has 4 sides, all pairwise equal. So the 2 opposite sides are equal in length. Here in the drawing, we have 2 sides of length L and then 2 sides of length W. That will tell us, by the way, that the perimeter, distance around, is 2 L's plus 2 W's. The area for a rectangle is length times width. So those are the 2 formulas that we're going to need, just perimeter and area. For a rectangle, the angles are all 90 degrees. Okay. All right, so there's that. So let's see about answering some questions. So here it says the length of a rectangle is 12 yards and the width is 5 yards. We're going to find the area and perimeter. Whenever you're given a problem involving a geometric figure like a rectangle, it's a good idea to make a sketch of it showing the appropriate parts labeled. So there's that. Here you'll notice that I labeled this 5 and 12, but in my drawing I have 12 as the side to side and the W is up and down. It doesn't matter which one you choose to be the length and which one you choose to be the width. If you turn it a quarter turn, you can relabel it if you want. Okay, so here 5 by 12 and 12 by 5 are going to be the same. Okay, if I drew this the other way, like that, then we would have the same perimeter and same area. Okay. All right, so let's go ahead and get the area first. So the area is going to be 5 by 12, and that's 60. The length unit here is 12, and so the length unit is yards, and so we'll have square yards for the area. Okay, so the units for the area are square yards. Okay, perimeter. Perimeter, there's going to be 2 sides of length 5 and 2 sides of length 12. So that's 10 plus 24, or 34 yards. By the way, it's really common for people to miss sides that are not labeled. You might have thought the perimeter was going to be 17 here. But remember that just because we didn't label a length, it doesn't mean that it's not there. So now the 2 yellow marked pieces of our picture should have a 5 and a 12 in them, right? Those sides count even though they don't have a number on them. Okay, here we're told the area of a rectangle is 609 square meters, and we know the width is 21 meters. From this, we want to find the length. Okay, we know that the area of a rectangle is length times width. We're told here that the area is 609, and the width is 21. So we want to use that information to help us find the length. So the length will be 609 divided by 21. 609 divided by 21. That's going to give us 2, which is 42. Then 189, and that will be 9. Okay, looks like the length is 29 meters. This time we were given the area and the width, and we had to find the length. Okay, here's one for you to try. Take a minute, pause the video, and work it out and see how you did. We were to find the length of a rectangle that has a perimeter of 30 and a width of 6. So we know that the width is 6. I don't know the length, but I know the width is 6. We know the perimeter is 30, so formula for perimeter is 2 times the length plus 2 times the width, We're given the perimeter, so let me replace P with the 30. The width is 6, so I'm going to replace the W 6. So we have 30 is equal to 2L plus 12. So 2L equals 30 minus 12. 30 minus 12 is 18. And so L is 9. 9, there was no units this time, so the length is just 9. Okay, next one. The length of a rectangle is 8 feet more than the width. The perimeter is 60 feet. We want to find the length and width. So here again, we're trying to find two things. We're going to do this just in terms of one variable. My problem is about a rectangle, so I'm going to draw a picture of a rectangle and try to label it appropriately. Here, the length is described in terms of the width. So I'm going to choose W for the width at our variable. And we're told that the length is 8 more than the width. So if that's going to be our length, it'll be 8 plus W. Okay, I have my picture labeled appropriately. The other piece of information I have is the perimeter, which is 2L plus 2W, is 60 feet. So let's replace with their values. W is going to be W, but our length is 8 plus W. Okay, so this gives us an equation just in W's that we can solve. So let's do that. So we've got 4W plus 16 is equal to 60. 4W is equal to 44. So it looks like W is 11. Okay, once we have the width, we were supposed to get the length also. The length is 8 more. 11 plus 8 is 19. Okay, so length 19, width 11. By the way, if you're using some sort of online software for this, where you have to enter the answers in the boxes, make sure you put the right one in the right box. It's a bummer to get the question wrong because you put the length in the width box and the width in the length box. If you're doing this on paper, like a paper homework or a test or something, make sure that you label what each one is instead of just writing 11 and 19. Okay, that takes us to the end of section 3.4 on some geometry examples or applications. We focused really on triangles and their areas, perimeters, and angles, and then we looked at rectangles and their areas and perimeters. Okay, so that's the end. Let me know if you have any questions, and have a great day.